Modern cloud architectures look calm on diagrams. Events flow, lambdas trigger, messages move. But production systems don't fail cleanly. They fail repeatedly, they fail partially, and sometimes they fail forever. Event-driven architecture does not remove failure, it distributes it, and once failure becomes asynchronous, retries stop being recovery mechanisms. They become amplifiers. In synchronous systems, failure is visible immediately. In asynchronous systems, failure becomes deferred uncertainty. This is why EDA requires a different mindset. We don't design for success paths. We design for failure behavior over time. Retries feel safe, but they are not free. In production, retries often create failure storms. Retries multiply load. They are not recovery tools. They are load replication mechanisms. At least once means sometimes twice, sometimes 50. Unless every consumer is idempotent, duplicates become data corruption. On AWS, retries are everywhere, often by default. Duplication is not an edge case. It is a guarantee. On AWS, failure handling is not a single feature. It is an interaction between services. You are defining how the system behaves when stress arrives. Step 1. Control retries at the source. Set maximum retry attempts. Set maximum event age. These two settings decide when the platform stops believing the failure is temporary. Step 2. Use SQS as a shock absorber. SQS is not just transport. It is a pressure regulator between systems that fail at different speeds. Step 3. Define a failure exit. A dead letter queue is not a trash can. A message in a DL queue is no longer a silent failure. It becomes an event the system is asking you to look at. Step 4. Make consumers idempotent. Use DynamoDB keys or conditional writes. Without idempotency, retries cause corruption. With it, retries become safe noise. Step 5. Prevent retry storms. Limit concurrency and fail fast instead of timing out slowly. Sometimes the correct response is stopping the blast radius. Step 6. Observe failure as a first-class signal. Monitor DLQ counts and retry rates. If failures aren't visible, the system just loops silently. Architecture is the explicit definition of these controls. This is not operational tuning. This is the design. But even with all of this, some events are not temporarily failing. They are fundamentally unprocessable. These are poison messages. Without isolation, they get retried forever, consuming compute, clogging queues, and hiding real progress. This is why every serious event system needs a failure terminal state. Not all messages should succeed. Some must be quarantined. Reliability is not built by adding retries. It is built by deciding when to stop and how to protect downstream systems. In event-driven systems, reliability is not the absence of failure. It is the containment of it.